was going to do video 4 on newtons and surface gravity, but I'm going to do number 5 on that. This video will introduce a little bit more about why a different kind of periodic table is necessary, or why I believe it's necessary, why it should be done. One of the things I wanted to mention was that most people who are not scientists have the impression that science is highly esoteric and that they can't understand it. And this is a similar view to how people view religious faith, believe it or not. There are aspects that are not explained in religious faith that you just need to accept, take on faith, let the whatever clergyman or member of clergy is your guide, just tell you what you need to know, and then you just continue to support that effort. I'm afraid that science has a little too much of that in it as well, that it's been made too esoteric. One thing, for example, if you don't have negative charge, there's no wormholes. In order to get wormholes, you have to have negative charge. If negative charge doesn't actually exist, and all you have are particles that have always existed, that had no beginning, and they get charged, and the charge is just simply surface distortion. Like if you put a bunch of, say, rubber spheres in a jar, took something to smash them in there, as if they're being compressed inside of a giant collection, let's say, and they're representing photons, they would become more cube-shaped. See, spheres have these spaces between them, but when you smash them, or compress them, they become more cube-shaped. See, the cube shape becomes the impetus for the eruptions into space, these binary eruptions that go in two opposite directions into space when this collection erupts. So you have that. It follows along with things we observe every day, type of things it's not esoteric. And so when they erupt into space, what's causing that is that they're spheres by nature, but they've been compressed into almost cubes. Some of them maybe all the way into being cubes, and then they're resisting that and wanting to push back, you might say. And so this creates a force, a collective force that needs to be released out into space. And so there you have the beginning of the movement of galaxies, and they would be in two opposite directions. And then when these particles flex back to being more cube shape, or to being more spherical shape, they retain a little bit of that cube shape to different degrees. That would the higher charged photons would be the ones that retain more cube shape as they come out. But they're almost all of them that have been compressed, highly compressed, flex back quite a lot, and they're almost spheres again, but maybe just a little bit distorted. And then they go on to operate as the higher charged photons, and then the ones that are more spherical, as those come out with those are the ones that are uncharged or very low charged. But anyway, so all of this is matched. This is not esoteric, you see. The number of protons in the standard model of the atom is what determines which kind of element a given nucleus is, and its surrounding, orbiting, hovering particles or whatever, which are included, of course. If the number of protons do not indicate which element it is, and if the number of neutrons don't indicate which element it is, but rather the combination of the two making a configuration, and that configuration determines what properties the material has and what element it is. And if the protons are milder particles than neutrons, as it turns out, when you study tritium, you would come up with that conclusion, at least I did. Then the number of protons can vary. The neutrons are more problematic. Loose neutrons on a nucleus would cause radioactivity. And so anyway, this is that kind of periodic table. As far as finding the which configuration fit each type of nucleus, each element. At first, it was just, the idea was keeping protons and neutrons separate, keeping neutrons separated with protons, so they didn't clap, so they didn't bang. And since the protons are attracted to one another, but not as much as to neutrons, and neutrons are attracted to other neutrons more, the neutrons would always come in first and start banging, and then the protons would come in as well, and then they would wedge in between them. When there's recoil, the protons would have opportunity to wedge in between a couple of them, so that a configuration can form in that way, whether it's 3 that are being kept apart by 6 protons like in beryllium, or 5 in oxygen that are being kept apart by, say, 2, 4, 6, 8 protons with some other protons on the exterior of that, or in carbon, where you have the protons get inside of 4 neutrons and wedge in such a way that it configures uniquely. If that's the kind of thing that's going on, that's what's being exhibited in this first installment of this new kind of periodic table, then that's why I felt it was necessary to develop this. Also, I came up with a methodology to determine which nucleus configurations could work for each element. You take the properties of that element, particularly whether it's at normal temperature and pressure or standard temperature and pressure, which is around 68 degrees or as low as 32 degrees Fahrenheit, in that range. If they're either a solid, a gas, or a liquid, and then how strong of a solid they are if they're a solid at that temperature, that has a direct bearing on which configuration would work, because what I contend with this approach is that the traction, the leftover traction from nuclei, is not only what causes acids and bases, which I have a chapter on acids and bases. It's rather lengthy in existence uniformity, because you have to explain acids and bases without negative charge. But also, you'd have this leftover attraction from nuclei collectively from a large celestial body emanating out into space and reaching another body, and then there would be mutual attraction. Gravity is always reciprocated. If you have a large body that would be a gravity source, there has to be something with mass that can reciprocate. It can reciprocate gravity with. There's no gravity from a body to something that doesn't have mass, and that's another reason why when they did the gravitational lensing experiment and they saw the photons bend as they went around the sun, that tells you that the photons have mass. If they didn't have mass, they wouldn't respond to gravity. Anyway, another thing about this is that since the gravity comes from nuclei and it's leftover attraction from those, then what needs to happen is you develop a way to quantify that attraction force coming from each side of the nucleus. And I did that with what I call attraction aggregates, which is explained in this table, this new table. And so when you treat it using that methodology for each nucleus, there's a lot of configurations. You think, oh, this is a nice symmetrical configuration, and it has the right number of nucleons. But it doesn't work out when you try to match it up with the material's properties, whether it's a strong solid, a weak solid, or a liquid at standard temperature and pressure, etc. So the attraction aggregates, what you need to do is, well, let's just say this. If you have a strong material, you need to have probably something like at least three sides of the atom that are strong enough, and you just quantify that. 172 is the number. I'm not going to go into how I came up with that, but that's the number where there's a transition between when you quantify this using attraction aggregates. Anything that was over that would be a solid. Anything below that would be a liquid or a gas. Now the range in which something is a liquid, that number, that's an attraction aggregate number, it wouldn't vary much from 172. It's a very simple math problem where you just take the rows of nucleons to a side and the distance from the side, depending on how many radial shells that given nucleus can hold, and the fullness of the outer one, etc. And then none of these have electrons proper orbiting them yet. All of these through scandium have only radial shells, and there's one radial shell yet to go now by the time I reach iron and copper, nickel, etc. There's going to be a neutrino electron shell that orbits, but with 6 shells and then a certain allotment of radio particles for each shell being assigned, depending on the number of protons versus neutrons in a nucleus. Whatever you come up with for that configuration, the rule is that the protons need to keep the neutrons separated. When you're configuring these, the neutrons have to be kept apart so they don't bang or clap. The wedge protons do that, typically coming in from both sides between 2 of them, or there'll be a number of them in a line or a certain configuration. But also, how those orbiting, hovering particles are allotted depends upon how many protons and neutrons are in the nucleus. Originally starting out, I was assigning 80 of those kind of particles per proton and 100 per neutron. Well, that didn't work out, and I had to change it to, I think I changed it twice, but I ended up with 100 of those being allotted for each proton and 125 for each neutron, and that worked out.